So we can just, prove this, right? So on the LHS, we have x square plus y square minus 2xy. And on the RHS, we have x square plus y square plus 2xy minus 4xy, right? So this cancels, minus 2xy comes on the right hand side. And on the LHS, we have 0. Is about algebraic identities. Now, algebra is familiar with like everybody of you, right? So let's start. Suppose you have this sequence. No, this is actually a series. So as I was saying, you might not be able to tell the difference between the two, but just by seeing, I think you can say that, okay, in sequence, you were writing commas, and in series, you are writing plus. So yes, you are thinking on the right track. Basically, if I have to tell you, series is actually the sum of, you can say sum or difference of the terms of a sequence, right? So this is a very basic definition, difference actually. Okay, let's say you have something like AR square, so on till, and it goes on till infinity, right? Meaning it is not restricted. It is, you can say, diverging, right? So the answer for this is a upon 1 minus r, and the condition for this, when this can be used, is that r has to be less than 1 and greater than minus 1, right? So you might be worrying that what is this a, what is this r? So you can just, remember this right now, right? Now let's solve a question based on this. So 1 plus x square, so on till infinity, right? So if you just compare it, can you say that, okay, this compared to this, that means my a is 1. This compared to this, ar is x. My a is 1, right? So r becomes x. Perfect. So if I put it in this formula, what should I get? 1 upon 1 minus x, right? So yes, you are correct. 1 upon 1 minus x. And since my r is equal to x, that means this is only defined for x less than 1 and greater than minus 1. Now you have something like this as well, right? So the answer for this is this and this condition. This is actually a whole topic in maths. We'll study it further. Okay. Now you have x plus y square plus minus x minus y square. So if you take the plus of it, what will you have? Let's write it. X square plus y square plus 2xy. You're taking the plus, right? So plus x square plus y square minus 2xy. So what does it become? Does it become 2 times of x square plus y square? Yes, it does. Now if I take the minus of it, what will happen? You will have x square plus y square plus 2xy minus x square minus y square plus 2xy. So you will have 4xy as your answer, right? So you don't have to remember it, obviously, right? This actually remains in the subconscious part of your brain, right? Now let's look at this thing. So, this is not to be remembered, as I'm saying. This is just to make you realize that, oh, this is also how you can use this identity, right? And this is used a lot of times, right? Let me tell you. That is the thing. This identity is very basic. Everybody knows a plus b whole square. But where is it used matters. So see, we are writing x minus y square in terms of x plus y square. And for that, we will have to make some adjustment. Similarly, we are writing x plus y square in terms of x minus y square, and some adjustment has been made, right? So we can just, prove this, right? So on the LHS, we have x square plus y square minus 2xy. And on the RHS, we have x square plus y square plus 2xy minus 4xy, right? So this cancels, minus 2xy comes on the right hand side. And on the LHS, we have 0 now. So 4xy minus 4xy, 0. So hence proved, right? Similarly, this also you can see. Now coming on to some other identity, very famous identity. Like initially this troubles a lot to people. So you have x cube plus y cube plus z cube minus 3x minus 3xyz equals to, now this can be factored in this factor and in this factor. So tell me one thing, if someday LHS is 0, then what does that mean? If LHS is 0, then that means my x cube plus y cube plus z cube is equal to 3xyz, right? So this actually means two cases, right? Either my this factor is 0 or my this factor is 0. Now this big factor can be again written in a special way. How? In this way, right? You can open it and you will see that, yeah, this is becoming this only. That's why we have made this 1/2 adjustment, right? Now tell me one thing, if this entire thing is 0, does that mean each of this has to be 0? Why? Because if you have x square, that thing cannot be negative. That thing can be 0 and that thing has to be greater than 0. So that thing can be you can say greater than or equal to 0, right? It cannot be negative. It cannot be negative because you can check for any number, right? Let's check for minus 5 square. You know, minus 5 square is still, you know, plus. It's 25, right? So that is the thing. So for this entire thing to be 0, all of the square terms have to be what? 0. That means x equals to y, y equals to z, z equals to x. This thing means that all three are equal actually. X equals to y equals to z. So we started from that if my LHS is 0, meaning this thing is happening, right? This thing is happening. So it has two cases. Either this is 0 or x equals to y equals to z, right? So good, you know, thing to remember. Now let's move on to the cube of two numbers. So x plus y cube is actually x cube plus y cube plus 3xy into x plus y. X minus y cube is x cube minus y cube minus 3xy into x minus y. Now a lot of people cannot really remember this. So for them, only one trick, you can say that when it is plus, so every operator is plus. When it is minus, so every operator is minus, right? You can say. Now, let's say we have x square minus y square. So that can be written as x minus y into x plus y. If we have x cube minus y cube, that can be written as x minus y into x square plus xy plus y square. So if we have to generalize it, xn minus yn, how will we do that? So one thing you can see that x minus y factor will always be there. So that's why I have written that thing. And now what about this question mark thing? So let's try to analyze. See, the power is 2 here, right? The power is 2 here. And here it is, you can say 2 minus 1. And similarly, power is 2 here, it is 2 minus 1. Power is 3 here, it is 3 minus 1. 3 minus 1. 3 minus 2. 3 minus 2, like that. So what you can say is, let me remove this question mark. So actually it is what? The power of x is, you can say decreasing, right? And the power of y is increasing, right? Okay. So you can say here it would be xn minus 1, right? And then it would be xn minus what? 2, yes. Then y, right? Then you will have so on till y power n minus 1, right? Perfect. Now this thing is obviously valid for, you can say, all the natural numbers, right? So your n can be a natural number here, natural number. Okay. You might think, what is this thing that I have made here? This is actually a symbol in mathematics. It's a Greek symbol only. This means belongs to. And if something does not belong to, so we just put a strike here. Okay. So n is a natural number, right? Natural numbers, you know, 1, 2, 3. Whole numbers are what? 0, 1, 2, 3, right? So on. So that is the thing here. Perfect. Now, what about if we had the plus operator in between instead of the minus operator? So one thing will happen here. What thing? That the n can now only be an odd
exams, this turns into confusion and blank moments. With one-to-one mentoring, every mistake is corrected and real improvement begins.